Centrifugal pump. So for today we would like to discuss about pump efficiency. So we have three types of pump efficiency that we should know in this topic. The first one is the manometric efficiency. First thing that you need to know is to calculate efficiency, you need to divide the power output over the power input. So efficiency here means how much we could get from the source that we have. So the basic idea is power output divided by power input. So we have three types of efficiency. The first one is manometric efficiency. The equation for manometric efficiency is power from manometric head over power imparted by impeller to water. So the power from manometric head can be calculated by using equation for power is rho GQH, and we need to very selective about our H here. If we want to calculate power from manometric head, we need to use manometric head. And if we want to calculate power from impeller, we need to use Euler head, because Euler head is head that generated by the impeller in the pump here. So the equation for power is rho GQH. So we substitute the value of manometric head for power from manometric head and Euler head to calculate the power imparted by impeller to water. And then we could cancel off the value of rho GQ here. So we have HM over HE. We could substitute the value of HE by 1 over G V2 U2 minus V1 U1, as we learned about Euler head previously. And then we could say that manometric efficiency is equal to GHM over V2 U2 minus V1 U1. So this is the diagram about we have a tank here connected, it's sucked by a pump here, and then it's transferred the liquid to the higher level of tank here. And then as we know that pump is rotated by a pump motor here, and to rotate by a motor here we need to connect the power motor here with a power supply. And then please think like this. For example, we supply 100 unit of energy from the power supply to the motor of pump. And then because the wiring here, some energy was lost. And then only 80 of them are capable to rotate the motor here. Then from motor to pump, it has its mechanical parts here. For example, we have shaft, we have a few type of motors, gear, and so on and so forth. So we have energy losses here. And then from 80 that motor pump received from the power supply, might be motor of pump here could only transfer about 60 energy to the pump. And then by using 60 here, so pump need to transfer all the energy from the impeller here to the water. And then let's say it could transfer 60 of them to the water from the impeller rotation here. And then now the water here have 60 extra energy in the liquid. And then this water will flow into a pipe here. And we learn in fluid mechanics 1 that for sure we have pipe losses here. So let's say pipe losses here will take another 20 energy. So it means that the total energy left is 40, and this 40 now will help fluid to transfer from the lower level to the upper level here. So means that what is the manometric efficiency? So manometric efficiency is the efficiency of pump to transfer its energy and to lift water to the higher level. That's why we take manometric head here is the output. It's the output of the pump, and we take power in the impeller. That's why we take Euler head power from the impeller as the input, because we are only want to know how efficient this pump transfer its energy until the outlet level here. The efficiency number 2 here that I want to discuss with you is the mechanical efficiency. The equation for mechanical efficiency is eta mech. So this symbol is eta. We learned about this symbol in boundary layer, I think. So mechanical efficiency is the power output over power input, and power output here is power at the impeller, and power input is the power at the shaft. Why it's happened? Because in manometric efficiency, power at impeller was become the input, but in mechanical efficiency, power at impeller is now become an output. So let's see the diagram here. So we want to calculate about the mechanical loss here, the friction between motor and pump. So if motor receive 80 energy and then it could only transfer 60 energy to the pump, means that it lost 20 energy in the middle here. So this is the mechanical efficiency, means the mechanical parts here, the design might be the friction, the touching between shaft and its casing and so on and so forth. It might be not so good, so it create losses and it takes 20 energy from the motor of pump here. So in this situation, we could found that the motor of pump means power that could rotate the shaft here is the input power. So we put it here as the power input, power at the shaft. And the output of this power is actually the rotational of the impeller. Means that the rotational of the impeller here will be the output in the system. That's why we take power at the impeller as the power output. So it will become power at the impeller is 1 over G V2 U2 minus V1 U1, and power input here normally will be given in the question because it's depend on the power supply or and so on and so forth. So sometimes in a simple question, we will take the losses in the wiring here is also calculated as mechanical losses. So means that whether you want to take from here to here or from the power supply to the pump, it's okay for you to calculate the mechanical efficiency. Because in certain textbook they will say that the losses in wiring and so on and so forth is too small, so we neglect the losses between power supply and motor. Sometimes we conclude that from the power supply to the motor here to the pump is all here is the mechanical losses. And this is the third efficiency that we need to know. It is called an overall efficiency. So it's symbolized by eta O here, eta 0 here. And we need to calculate the overall efficiency. Means we need to calculate from the power supply, power that we supply to the motor, and the rotational of pump and the losses part in here and so on. What is the output at the end here? So we calculate the total output divided by the power input. And the power output here is the manometric head, because this is the final version or the final product, the final capability of our pump to transfer water from low to the higher level. And input here for sure the power that comes from the power supply. So it will become power output is rho GQ manometric head divide the power input, usually the power supply, because we always know what is the power supply of pump, how many watts and so on and so forth. And for instance, we could have overall efficiency by multiplying manometric efficiency, and mechanical efficiency. So I hope you could remember all these three efficiency equation, and please be careful to construct the definition of this efficiency. The most common mistake by student is student do not know when to use power by impeller as input and when it's become an output. The best way to remember this is you need to draw a diagram like this, and you could know what type of efficiency you want to study, and you could determine which one is input and which one is output.